When two entities have a one-to-many relationship, we find that some of the data is present on the one side of the relationship and some of the data is present on the many side of the relationship. Consequently, we have two entities, or now two tables, that hold data. We might, at several points in time during a data analytic process, use data from one entity and combine it with data from another entity. So, in some way, we need to bring the data that is present in these two entities together. The way we can do that is through the use of an SQL query. The SQL query allows us to join the two tables based on the one-to-many relationship that has been established through the use of primary and foreign keys in the two tables. To start off with and to demonstrate this concept, let us use the text database. In using the text database, there are two tables that I want to point out, and I will be displaying the data from both these tables simultaneously. There are two tables called nation and stock. Nation is a table whose primary key is NAT code. As one can see over here, we have NAT code as the primary key of nation and two other attributes, NAT name or nation name and exchange rate. And so this is the currency exchange rate as compared to the UK pound, where the UK pound is 1 and every other exchange rate is with respect to that UK pound. The other table I would like to point out is the table stock. In the table stock, which is very similar to the table share, the stock table has stock code, stock firm, stock price, stock quantity, stock dividend, and stock PE or price to earnings ratio. In addition to these columns about stocks, this table has another column called NAT code. This NAT code column is the foreign key in the stock table, and the values of NAT code in this table correspond to the values of NAT code in the nation table. Consequently, NAT code in the stock table is on the many side of the relationship, as NAT code such as UK shows up multiple times in the stock table as a foreign key. These two tables, nation and stock, have a one-to-many relationship. The one side being the nation side, where NAT code occurs once as the primary key, stock table being on the many side, where NAT code as a foreign key shows up multiple times. Consequently, we would like to join these two tables, bring these two tables together based on the primary key foreign key relationship. To do that, through the use of an SQL query, we need to do the following. I will be writing select star because I want to bring all the data together in one query. Select star selects all the columns from these two tables from the nation table. This by itself selects all the columns from the nation table, but I want to bring the stock table into this as well, and so what I will be doing is I will be writing a clause called join. I'm going to be joining the nation table to the stock table. Now, if these two tables are joined, I need to specify what is the relationship between these two tables. On what columns do these two tables get joined? And so I shall say that the nation table is joining the stock table on nation tables nation dot NAT code. So the primary key of the nation table, that value is going to be equal to the stock table's NAT code, or the foreign key in the stock table. This statement, select star from nation join stock on nation.natcode is equal to stock.natcode joins the two tables together on the primary key foreign key relationship. When one executes the statement, one sees that the first three columns, nat code, nat name, and exchange rate, are from the nation table. And they're from the nation table because nation table showed up first as part of the from clause instead of the stock table. The rest of the columns, stock code, stock firm, stock price, quantity, dividend, PE, and nat code, are columns from the stocked table. Now notice that because these two tables are joined, nat code in the stock table, where nat code is AUS, is joined with nat code in the nation table, where nat code was AUS. This happens for other values of nat code as well. One might wonder what actually happens if you flip the sequence of these tables around. To do that, one only needs to try select star from stock. I'm flipping the order of the tables. Select star from stock. Join the nation table on stock.natcode is equal to nation.natcode. If one flips the tables around, and so instead of nation, from nation join stock, I'm having from stock join nation, the only difference is that stock columns are displayed first before the nation tables columns. One might also wonder, does it matter the order of the equality? What if I did select star from nation join stock on stock.natcode is equal to nation.natcode? Is there going to be any difference? So I have flipped the equality, and if I run this, one will notice that there is no difference. Nation tables columns show up first, stock tables columns show up after. The flipping of the equality makes no difference in what shows up. Now remember, the other parts of SQL that we have learned before this still apply. We can still select the columns that we want from each of these tables now. Now we have two tables from which we can pick the columns that we are interested in, as long as this relationship exists and is expressed through the use of the join clause. One might also wonder, what if I don't have that equality? What if I just say select star from nation join stock without the on clause? What is the consequence of that? Well, if you have two tables that have a one-to-many relationship, the first thing you want to do is avoid doing this. But let's see the consequence of that. Select star from nation join stock. Please note that I don't have the on clause, and this is the wrong way to do it. If I run the statement, I will see a lot more results. I will find, in fact, 64 rows returned instead of the 16 I should expect. And here is the reason why. Stock Abyssinian Ruby that has a nat code of UK, that is the foreign key of UK, is joined to every nation. It is joined to nat code Australia, India, UK, and USA. In fact, each stock is joined to every nation rather than the specific nation that corresponds to its foreign key value. And so this query over here gives you a Cartesian product. You have 16 rows that are present in the stock table. You have 4 rows that are present in the nation table. 16 times 4 is 64, which is why you have 64 rows returned, because every value of stock is joined to every row in the nation table rather than a specific row in the nation table. Please avoid doing this. Whenever one has a join clause, it needs to be followed by the on part of that clause. One of the important clauses in SQL is the group by clause. Group by clauses allow us to create aggregations based on values in a column. Let's take a look at an example. Before we take a look at an example of the group by clause in a one-to-many context, let us take a look at how do we use a group by clause when we are working with a single entity. To start off with, let us take a look at the table stock. We can see in the table stock that we have various stocks that belong to certain nations or NAT codes. In fact, there are repetitions of values of NAT code in the NAT code column of the stock table. If I order the results, we see that there are, through a count, 3 values of AUS, that means there are 3 Australian stocks. There is 1 IND, so 1 Indian stock, a bunch of UK stocks, and 2 USA stocks. Now, while we have done that visually, we can use SQL and the group by clause to actually give us this count based on values of NAT code. Here is how we use the group by clause. In this case, we want to actually print out the value of NAT code and count how many times that NAT code occurs in the stock table. So I would be selecting the NAT code column because I want to print out values of NAT code. In addition to that, I want to do a count. This count is of the values of NAT code from the stock table. Now, in this case, I want to aggregate. I want to create an aggregation. I want this count to actually count each distinct value of NAT code. So what I would do is say group by NAT code. What this does is, as we run it, it prints out the value of NAT code, each distinct value of NAT code, and counts how many times that NAT code has occurred in the stock table. This is the purpose of a group by clause. The group by clause allows us to create aggregations based on unique values in a specific column. In this case, the column is NAT code, and I'm counting the times NAT code occurs in that column. Now, while I have done count of NAT code over here, another way to express this is instead of count of NAT code, I can also count star. Star represents rows. I'm still going to get the same results. In this case, I'm counting the number of rows where the NAT code is Australia, the number of rows where the NAT code is India, and so on and so forth. I will still get the same result. We can see that group by clause allows us to create these kinds of aggregations. Now, we can run this for any sort of function. While I'm using count, I could also do a sum, and in this case I could sum up the stock quantity. So how much stock do I own from each of these different nations. In this case, this tells me how much stock do I own in Australia, India, UK, and USA respectively. And so I can apply a variety of aggregation functions in the select clause, and with a group by, I can get those aggregates for unique values in a certain column, in this case, NAT code. This demonstrates the use of the group by clause when applying the group by clause to a single entity. We can do this in a one-to-many relationship as well. While we have seen that we can get NAT code out and the sum of stock quantity from stock, grouping by NAT code is not very informative. It might, in fact, be more useful to get the name of the nation that that code corresponds to. The thing to keep in mind is that the name of the nation is not present in the stock table, it is in fact present in the nation table, and these two tables are joined by the one-to-many relationship. So what I can do is I can select NAT name that holds the name of the nation, which is part of the nation table, and get the sum of stock quantity. Now notice that NAT name is in the nation table and stock quantity is in the stock table, so we have two different tables over here. So I need to have both tables in my SQL query, so from nation. Now if I need both tables in my query, these tables have a relationship, and that's the one-to-many relationship. And so I need to join these two tables. So I shall say join the nation table to the stock table on nation.natcode being equal to stock.natcode. I still want the aggregation for every nation. And so what I could say is group by nat name. What this will give me is every nation's name and the sum of stock quantity for that nation. The result for sum of stock quantity will be exactly the same as in the previous query, but in the previous query you had NAT code. In this query, we in fact have NAT name. And this is how we can use the group by clause as part of a one-to-many relationship. Now a variation of this is not to group by NAT name, but to still group by NAT code. Let's take an example. We can write the very same query, but instead of grouping by NAT name, we can group by NAT code. Now, if I run this query, I'm actually going to get an error. Let's see what the error is, and let's try to interpret how we solve that error. As you can see that this query didn't run. I just hit Control Enter, and we have an X mark right here. This says the error code is 1052, column NAT code in group statement is ambiguous. Ambiguous suggests something, and it is on us to interpret what that means. NAT code in the group by statement is ambiguous. Why should it be ambiguous? Maybe because we have two columns called NAT code. NAT code exists in the nation table and also in the stock table. So SQL, when it comes by group by NAT code, is trying to interpret which NAT code am I referring to. From our perspective, it makes no difference which NAT code is used, but to SQL, this might be problematic. And so what I'm going to tell it is group by the nation table's NAT code column. We can use the stock table's NAT code column. It makes no difference. We need to specify which table's NAT code column we are referring to. If we run this, we will get exactly the same results as we did if we used NAT name. And so one can see there are different ways one can use the group by clause. The having clause is related very closely to the group by clause. The having clause restricts the results of a group by. after we have created our aggregations, the having clause allows us to pick which ones we want. For instance, let's say I want only those nations where my sum of stock quantity is greater than 500,000, for instance. So, how do I get those results? I would need to rely on the having clause after I have created my aggregations. For instance, select nat name with the sum of stock quantity from the nation table joined with the stock table on nation.natcode equal to stock.natcode. I'm going to group by nation.natcode. So now I only want those countries where I have more than 500,000 stocks. And so I shall say having the sum of stock quantity, where that sum is greater than 500,000. And if I run this query, I will get the two countries where the sum of stock quantity is greater than 500,000. The purpose of a having clause is to restrict the results of a group by. One can apply this to sums, counts, anything one chooses.